Menacing machine-learned molecules. Collaborations Pharmaceuticals, based in Raleigh, North Carolina, was doing incredible cutting-edge work in drug development using AI. It had designed what it called a molecular generator. This technology uses AI to combine virtual molecules via advanced computer modeling to assess resultant combinations for use as medicine. The company's work was so good, the team was invited by the Swiss Federal Institute for Nuclear, Biological, and Chemical Protection, also known as SPIE's laboratory, to do an experiment. SPIES works to identify developments in chemistry, biology, and enabling technologies that may have implications for the Chemical and Biological Weapons Convention. Every 2 years, the conference brings together an international group of scientific and disarmament experts and basically asks them, what kind of weapons do you see now and in the future, and how can those threats be managed internationally? In 2021, SPIES asked Collaborations Pharmaceuticals to contribute a presentation on how AI technologies for drug discovery could potentially be misused. The Collaborations Pharmaceuticals team, led by Dr. Fabio Urbino, coded its model to combine virtual molecules in ways that, rather than avoided toxicity, prized it. In a mere 6 hours, their software generated 40,000 virtual molecules that fell within the researchers' predefined parameters for possible use as chemical weapons. Urbina's team was stunned. Because data on this experiment was published so recently, in March of 2022, little about the results has been decided ethically. Thankfully, Urbina's team withheld publication of its methods and did not physically synthesize any of the molecules, but it did raise ethical questions immediately. Should the scientific community create rules and restrictions for access to this science? How do we prevent bad actors from taking what we vaguely described in our paper to the next logical and harmful step? If our drug development AI and others is misused, how will this technology be perceived? Urbina goes on to raise a cloud of worry. Several hundred companies around the world already use AI to develop drugs. They simply hadn't conceived of designing biochemical weapons. Collaborations Pharmaceuticals own commercial tools, as well as open source software, and many data sets are available with no oversight. Urbina's team suggested in its paper the immediate need to monitor software downloads and restrict sales to certain groups, develop an API for public usage, develop safeguards that monitor AI-powered drug discovery software for abuse. Urbina didn't offer any answers to preventing bad actors from taking his team's science to the logical, harmful step. He does write, with a global array of hundreds of commercial companies offering chemical synthesis, synthesis is not necessarily a very big step. Urbina's technology has obvious appeal to terrorist groups and to nations that haven't ratified or don't follow the Chemical Weapons Convention. In terms of misuse, the team worries its science will likely be placed under moratorium or banned outright and will add to the hysteria over AI. Two creative projects that have been examined or contributed to this ethical debate are the 1971 film The Andromeda Strain and the video game Eterna. In The Andromeda Strain, scientists run a computer model, a fictional but very close prophet of AI, to predict growth and mutation rates should the alien microbe Andromeda run amok. The model stalls unexpectedly in its calculations and throws up a menacing code, 601. The numbers are too large for the computer's process. That is how dangerous Andromeda is. I imagine Urbina's collaboration software team had the very same stunned reaction to its computer model when it so rapidly came back with its massive, terrifying data 40,000 virtual toxic molecules in 6 hours. The video game Eterna was a molecular chess game that challenged players to fold RNA molecules to create shapes. By adding solved molecules to a database, Eterna played a key role in helping researchers build more powerful automated algorithms for biological discovery, the very work Urbina's team was doing. What we're looking at here is not just some far-out lab research. It's important we learn about this ethical debate. AI-powered drug discovery research is a great advance for medication. It's a method for increasing the pace of discovery in science. It has the potential to be used extremely dangerously, however, on the world stage to engineer weapons, to release weapons, to threaten to release weapons, and to cause general chaos. The research is a vital path to help countries stay ahead of global threats and learn how to counteract attacks with vaccines and drugs. More broadly, AI is everywhere. There's a lot of fear around it, so it's good to learn what AI actually can and cannot do. We as students studying science and ethics need to be very familiar with leading-edge scientific debates. We could be weighing in on them one day. Two prominent voices ask us to think about the use of AI in ways that are specific to this drug discovery case study. Elon Musk, in Werner Herzog's documentary Lo and Behold, says, "The risk of AI is not that AI will follow its own will, but that it will follow the will of the people that developed its optimization function. If that function is not well thought out, then, well, we can see that alarming, dangerous, unpredictable, massive, and sometimes unstoppable outcomes can result, as we saw with Urbina's team." Andrew Ng is an AI kingpin. He's the founder of Deep Learning AI, co-founder of Coursera, founder and lead for Google Brain, and former chief scientist at Chinese tech company Baidu. In his course, AI for Everyone on Coursera, he says AI is a major technological disruption, and that those using it must always strive to make sure the AI system you hope to build makes society better off. We can see through collaboration's pharmaceutical startling discovery how easy it is to have a blind spot when it comes to building an AI system. This scientific advance has thrown computer-aided drug design into question. It is clear the world's researchers need a 360-degree view of science. And that view is not easy to climb up to.